Hello and welcome to another tutorial on dev.java website. We are looking at the built-in array types, and so far we looked at how to declare arrays, how to create and initialize them, how to copy arrays, and now let's look at array manipulations. Arrays are a powerful and useful concept used in programming, and we said that in C++ arrays are built-in types. Java followed the same concept, but they try to inherit from object class. So arrays are built-in types, but there is still some sort of object. They have object properties and they have extra fields such as length, so that the array keeps track of the number of elements in the array. Java Standard Edition provides methods to perform some of the most common manipulations related to arrays. For instance, the array copy demo example uses the array copy from the system class. And we look at this, we said that this is a native method which reaches into the JVM C++ implementation and knows how to do efficient byte copying of the arrays, right? Because arrays are contiguous block of bytes in the memory. Instead of manually iterating through the elements of the source array and placing each one into destination array. So we don't want to do that, because if you write a manual for loop and try to copy like 1000 elements, it's very inefficient. This is performed behind the scenes, enabling the developer to use just one line of code to call the method, right? And I said that it's better, instead of using this, use the arrays class, which is a utility class. And the convention in Java is that whenever you have some sort of class, let me just write it down. So the convention is that whenever you have some sort of class, let's say you have some array, and then a utility class, the convention has been a utility class comes with it, and it's the name of the class but with an S, which means this is plural, which means this is some sort of extra, right? S means plural, or which indicates that some extra utility functions. For example, arrays, right, with S. For example, the collection interface, it comes with a utility class called collections with S at the end, right, which means this has some utility classes. So later on, when they added the support for static methods and default methods in interfaces, most of these utility methods, for example in collections, can be added to the collection interface itself. With arrays, that's not the case, because as I mentioned before, array is a built-in type, so it doesn't have any interface or a class definition associated with it. That's why this arrays is still the only way to introduce utility methods, right? For your convenience, Java provides several methods for performing array manipulations, common tasks such as copying, and we said that the method is copy of. And the static copy of methods, it also specializes on the built-in types like primitive array types, and then it behind the scenes calls this array copy from the system class. But the fact that it's type safe, it allows to differentiate between primitive array types and object array types. Sorting, we know that for primitives, sorting is meaningful. For objects, you have to implement the comparable interface, so that you give your own classes a natural ordering, so that Java knows how to order them at runtime. Searching arrays, we know that if you have an array and you want to sort them, you usually, or you search them, for example, you want to find a particular element, you have to override the equals and hash code. And also comparable. In the java.util.Arrays class, for instance, the previous example can be modified to use the java.util.Arrays method. Use the method of the java.util class. Actually, this is not correct. I believe this is a typo. This should be java.util. The method should be copy of, right? So it should be copy of range, for example. So this should be java.util.Arrays copy of range. So they forgot there's a typo here of the java.util.Arrays class. As you can see in the array copy of demo, the difference is that using the java.util.Arrays method does not require you to create the destination array before calling the method, because the destination array is returned by the method, right? So we saw that this array copy doesn't return anything. Its return type is void. So you have to create your empty array which has already been created, and you just pass the reference to it. And then because these are objects, you can pass objects by reference and then mutate the state of that object, right? Obviously this is not the case for primitive types, because primitives in Java are always passed by value, which means there's always a copy created. With references, you also create a copy of the reference or a pointer, but as long as it's the same reference or the same pointer, you still have access to the actual object data or the state of the object, whether through the actual reference or a copy of the reference, because both are pointing to the same object in the Java heap. Now the same story, we have a string array and then java.util.Arrays dot copy of range. Copy from, this is the original array, from index to 9 elements, and then this returns an actual array. And these are type safe. We saw that this is actually generalized. So if I open up java.util.Arrays and copy of range, this is this is a generic method because it is aware of what type of array you pass to it, and then based on the type that you pass, it knows what type to return, right? We said that the system array copy doesn't return anything, and it only specializes on the object type. And we discussed why they decided not to go with a generic type for the basically here we discussed in the previous lecture why they decided to go with the object instead of trying to make it a generic method, because then this is inferred by the Java compiler based on the way that the generics are implemented in Java. This is replaced by an object array, not object, and that can cause performance issues, right? So they decided to avoid this, go with object. Obviously you cannot pass any object to it, you have to pass an array type. So there are some checks here to make sure that this object is actually a type of array, otherwise it's going to throw an exception. However, all the methods in the arrays class, all these static methods are completely type safe. They either use generics for object arrays or specialize on the copy of range, specialize on the basically primitive array types. And those are all type safe, and it's always recommended for you to use those. As you can see, the output from this program is the same, although it requires fewer lines of code, and it's definitely type safe, right? Because it knows what type of array you're passing, and therefore it knows what type of array to return. Note that the second parameter of the java.util.Arrays method arrays basically copy of range. They're trying to refer to this method, but for some reason they forgot to let's go back here. They forgot to add this copy of range name of the method is the initial index. So you start from the offset, because we know that the reference or the array name is a pointer to the first element, so you give it from which offset? Index 2, 0, 1, 2. So from the third element, remember that arrays indexing starts from 0, or offset starts from 0. Is the initial index of the range to be copied inclusively, while the third parameter is the final index of the range to be copied exclusively, which means the 9th index, which is the 10th element, is not going to be included. So the range, the initial index is inclusive, the last index is exclusive. And this is typically the similar concept in all of the programming languages when it comes to a range of indices or indexes. Same in Python, for example. Let me open up a terminal. So in Python, for example, indexing or slicing, you have an object, let's say a string array, and then you say 2 colon 9, right? And this means that go from index 2 inclusive, so index 2 is included, but the last index, which is index 9, is not included. So this is the same concept basically everywhere in the computer science when it comes to range. When you say in Python, when you say range 1 through or 2 through 9, this creates 2, 3, 4, 5, 6, 7, 8, right? Same with Java, for example, if you have a string and you call the substring, right? You have a string and then you call the substring method, right? And then you have one of the overload is to give it 2 index 2 to 9. So from character 2 to character 9, but 2 is included, 9 is excluded. So whenever you deal with ranges in computer science, it's typically that the start index of the range is included, the last index is excluded. All right. All right, so index 9 in this example is excluded. Some other useful operations provided by method in the java.util.Arrays is searching an array for a specific value to get the index at which it is placed, and it uses a binary search method. So let me just create a new class, arrays demo, for example. We're going to have a main method. So let's use the same example here. So we have this string array, okay? And now we want to start a search. So we want to find the index of element that is cappuccino, right? Cappuccino. So we're going to say arrays dot and arrays is in the Java util, so it's not in the Java lang, so you have to import it, right? So so let's say var x or index I1 is arrays dot basically binary search, and then it specializes on the object type, object arrays, or any basically any object array or even a generic array. So we're going to say binary search, right? And then we're going to pass the copy from, and then the key is going to be what to search for. Let's say cappuccino, and then sysout I1. So what does this return? So if it cannot find it, if it can't find it, it returns the index into the array. So sysout basically copy from at index I1. Yeah, it found it. What about if something that it cannot find it? Then it's going to return, I believe, a negative index, probably -1. We can check it. So I2, and I2. So we get 2. So this was able to find it. Let's search for this one, cap, and -3. So when it cannot find it, it returns a negative index, but that's not determined of what index is going to return. And because we are trying to access a negative index, obviously it throws out of bound exception. Note that in Python, for example, in Python for lists, they allowed negative indices, which means it just goes from the end. Obviously Java and C++, Java and C or C++, they don't allow this. They don't allow this because it can cause a lot of confusions, especially with this kind of API, that when you're searching, if you cannot find anything, it returns a negative index, for example. Obviously, if the negative indexing was allowed for arrays, then this kind of API doesn't work because you still get an element, which is not good. Now in C++, what they did is, for example, in the std string, when you try to find for a character, they created a special type, which is a string npos, which means no position or negative position, whatever you want to look at it. And instead of returning actual a negative index, they return this type of object. It's kind of like a type. And then when it returns the index, if you compare it with this special type npos to see if it's a valid index or not. But in Java, they decided just to return a negative index, and the negative index means that the element was not found, right? Okay. And I believe there's nothing special about this negative value. If you look at the API, the return type, it's really not special. It doesn't tell clearly what the negative value is going to be, right? So the return value will be greater than or equal to 0, which means it's a valid index if and only if the key is found. But there is no guarantee that what the negative value would be if the element is not found. Although here it mentions something about that index of the search key if it is counted in the array. So it says that if the if the element is not found, minus insertion point -1 return. So actually they try to make their negative value deterministic. deterministic. Minus insertion point -1, I believe what this means, so the insertion point is defined as the point at which the key would be inserted into the array, and this is based on the sorting, right? The index of the first element greater than the key, or a dot length if all elements in the array are less than the so strings already have the implement the comparator. So if you try to open up the string type, I want to open it up from JDK 16, and they already implement the comparator. So the less than or greater than operators are defined for the string types. Therefore, basically what the binary search tries to do is tries to sort these, and so this is already kind of sorted, this array. And then if and then it uses the comparable or compare to method to compare these elements for the binary search. If it finds it, it returns the index for the equality. If it not, it looks at the sorted element and sorted array and try to see where this could have been. So cap is greater than a Americano but less than this one, so it's kind of like or greater than this and less than corrector, so it should be here in the index 3 minus index -1, so something like that. But as long as far as we are concerned with the searching and finding the element, if the binary search returns a negative index, it means it couldn't find it. Now binary search works with sorted arrays, right? So we can also sort, for example. So searching, sorting, var a1 is arrays.sort, and again it specializes for the primitive array types, object array or a generic with a given comparable, for example. So let's go with the object array, and we're going to say copy from, and then this is going to this sort I believe doesn't return anything, it returns void. So what happens is that it's an in place sort. So sysout, and we said that if we want to print the contents of the array, we call the to string or to deep string based on whether the array is one dimensional or multi-dimensional. So arrays to a string, so copy from. So this is the sorted, and the original array was already sorted. So let's change the order of the original array. And as you can see now, the last two elements are correctly sorted. So again, this method sort assumes that the object array that you're passing, the object actually has the natural ordering defined, and natural ordering means you have to declare or implement the comparable interface if you're using a custom class that you already wrote, right? Either that or use the other variant of the sort that takes a comparable, and then it has parallel sort. It just goes parallel, parallel sort. There are also other variants of the sort that takes a comparable. So you give it the array type, a comparable, and then it applies that. It uses a legacy merge sort. So it's using merge sort algorithm or team sort. So there are different types of sort. Obviously, if pass null, it just goes with the default sort, assuming that the object array, this T type, has already implemented the comparable. So if I pass null, saying that I use the other overload of the sort, but I'm not going to provide any comparable, then it assumes that you're going to use the default. And if, for example, a string didn't implement comparable, then you get a runtime exception, right? This is not a compile time checking, it's a runtime checking. But we can basically create our own comparable, right? And comparable of, not comparator, let's see. Yeah, we have to provide a comparator, and then of a string. And then we're going to, let's see. So new comparator. the type new comparator of a string, right? And then must implement the inherited abstract method compare. So right click, source, and then basically override implement methods, comparator, compare, and then we're going to provide how to, if we pass two strings, how to sort them, right? So the convention is that if logically O1 is less than O2, we want to return a negative number. If O1 equals O2, logically we want to return 0, and O1 is greater than O2, we want to return a positive number. And note that if you already have some experience with the comparator and compare, you know that this kind of equality concept should not collide or be in contrast to the dot equals, right? So if if this compare returns 0, which means the equals method also has to return true, right? I mean, otherwise the behavior could be undefined. So what are we going to do? We're going to say that if O1 dot length is equal to O2 dot, I want to sort based on the length, O1 O2 dot length, then we're going to return 1 plus 1. Else, if O1 dot length is less than O2 dot length, we're going to return minus 1, and then else we're going to return 0. Else we're going to return 0. And know that we have to return an int, right? So now we are sorting, and here I'm, instead of natural ordering of the strings, which is alphabetically, I'm sorting based off the length of the strings. So let's run this. And as you can see, 5, and then 6, and then 6, and then 3, 6, 7. As you can see, now we are sorting based on the length of the strings, and I can actually write a for loop for a string or var s in copy from after sorted. What I'm going to do, I'm going to do a sysout and then say that a string dot format, and then what I'm going to do here, I'm going to print the string and then also print the length, right? So s and s dot length. And as you can see, we are now sorting based on the length of the strings, and the way we did it in place comparator. Now obviously we didn't have to do this. We could use the very nice API of the Lambda expression. So instead of saying this and going through these anonymous inner classes, we just say that s1 s2 and then do a multi-line Lambda expression. And we can basically comment all of this. O1, O2, or S1, S2, S1, S1, S2, and S2. And note that with this notation, the compiler already deduces what the type of S1, S2 is going to be. I believe at the latest versions of JDK, they added this var, because these are still local variables, and var by definition can be applied to local variables, or you can manually type the string, right? That's fine, but the problem is that you cannot mix the specialized type with the var, so you kind of need to go either both var or both basically type, or you just leave the type out. The compiler can deduce that, right? So this should still work fine. Yes. So this was about sorting and some of the utility array utility classes or utility methods for arrays, which are very handy. Searching, sorting, creating a stream of the arrays. Again, you just say arrays a stream, and then you can do some operations. So let's say, for example, creating a stream of built-in arrays. Let's say I have a double array, x1, and it has lots of elements, 1.1, 2.2, 3.3, and then 10.5. Let's say it has these elements, and I want to apply a given function, let's say sinusoidal function, to all these elements and create a new array. So I can say x arrays. So I create a stream, arrays, a stream. It specializes on the primitive types x1, and then we're going to use the map, and then double unary operator. So t, any element goes to math.sign of t, right? And then to array again, and we can say double array y1, right? And then we can say sysout arrays to a string x1, and then sysout arrays to a string y1. And as you can see, we are calculating the sign, and the nice thing here is that you can also extract this as basically as a method reference. So instead of telling this, you can just say math scope resolution operator sign, and it already knows that the Lambda expression how to bind this method reference to this interface double stream, and this still works fine, right? Yeah. So whenever you have primitive arrays and you wanna iterate through them, you can do this. You can even, after this, call the parallel to just use a fork join multi-threading and go parallel, right? Obviously, for a very small array, parallel doesn't make sense. It actually hurts the performance. Definitely use this kind of streams and then map to apply a given function to a primitive array like double array or int array, etc., and then collect them to array, right? It's easier than writing the for loop. Obviously, you could do the for loop, but the problem is that you have to create your result array first based on the length of the original one. So a few more lines of code, but this stream makes very nice use of the stream API, right? And then to a string, we saw the to a string, and we said that if you have a multidimensional array, you have to use a deep to a string, and then it goes through each element of the array. If that element is already an array, it goes inside, so it recursively goes inside. All right, wrapping up, the Java programming languages uses both fields and variables as part of terminology. Fields means variables associated with the state of the class. Variable is more like local variables. Instance variables are unique. Class variables, static fields, they're not associated with the state of a particular instance, right? And then local variables store temporary states. We said that the best practice is to declare them as final unless you really need to change the values. And then primitive types, we definitely look at this. We said that strings are not primitive built-in types, but they are final and immutable, so you can always treat them as built-in types. And then a literal is the source code represents the fixed value. And again, these are something we looked at before. Integer literals, float literals. Array is a container object that holds a fixed number of values, and it's supposed to store them in the Java heap as a contiguous block of memory, which makes it very efficient for retrieving the values in the array or navigating through the array. Because if you have the pointer to the first element going through like a specific offset, it's very easy, right? The length of an array is established when the array is created. After creation, its length is fixed and can never be changed. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.